So this is absolute value function y equal to a, the modulus of bx plus c plus 50. So the first step, we have to find the vertex for our absolute value. So we have two types of absolute value. This is the vertex. It looks like a quadratic graph except that this is more sharper. It looks like a V and A. So to find the vertex, we have to take the thing inside the modulus, let them equal to 0 and solve for x. So it will be x plus c equal to 0, and then we're going to solve for whatever value of x. Once we know the value of x, we're going to substitute them back here, and then check what is the value of y. So this is our vertex. Once we know what is our vertex, we're going to draw the shape of the graph. So this is actually depends on the value for a. So we must check either the a is greater than 0 or a is less than 0. So if a is greater than 0, we're going to have something open upward. A less than 0, this one must be open downward. So once we have the first and second step, we're going to try to draw them first, and then once we draw them, we're going to check whether do we have x-intercept and y-intercept. So if we have them, then we're going to calculate what is the value. Okay, so let us go to the first example. So we have y equal to the modulus of x minus 2 plus 1. So to find the vertex, the thing inside the modulus should be equal to 0. X minus 2 equal to 0, x is equal to 2. So once we know x equal to 2, go back and try to substitute. So y equal to the modulus of 2 minus 2 plus 1. So we got 0 plus 1, which is actually equal to 1. So that means the vertex is 2, 1. Okay, and then we're going to check what is the shape of the graph. So basically the number in front of the modulus is 1. So a is equal to 1, which means a is greater than 0. Therefore the graph should look like a V. So let us plot the x-axis and y-axis. So the vertex is at 2 and 1, and the graph looks like a V. So let us draw that one. Okay, as you can see, we didn't have any x-intercept. We only have y-intercept. So x-intercept does not exist, so no need to calculate. Y-intercept, we have to calculate them. So this is x equal to 0. So y is equal to the modulus of 0 minus 2 plus 1, which is simply 2 plus 1, and this is equal to 3. So this value is y equal to 3, and the graph is y equal to the modulus of x minus 2 plus with 1. So this is the first example. Let's proceed with the second example. So we got y equal to negative 2, 3 minus x, the modulus of 3 minus x plus with 1. So firstly, let us calculate the vertex. So take the thing inside the modulus, let them equal to 0. So negative x equal to negative 3. X should be equal to 3. So we substitute back x with 3. So y equal to negative 2. 3 minus 3 plus with 1. So this one is negative 2 times 0 plus 1. So that means y must be equal to 1. So that means the vertex will be 3, 1. So once we know the vertex, the shape of the graph, so as you can see in front of the modulus, the value is negative. So a is negative 2, a is less than 0, so it should be a. Okay, so let us try to draw the graph first, x-axis, y-axis. So 0, 1, 3, so the vertex is 3 and 1. And then let us draw the shape of the graph. So this is the shape of the graph. As you can see, we pass through the x-axis and the y-axis. So that means I have to calculate both the x-axis, the x-intercept and the y-intercept. So let us calculate what happened when the y is equal to 0. So I have 0 equal to -2 modulus of t minus x plus with 1. So -1 equal to -2 t minus x. So 1 over 2 is equal to the modulus of t minus x. So that means t minus x is equal to half. Or we can have t minus x equal to -half. So for this one, this simply means that x is t minus half, which is 5 over 2. For this one, x is equal to t plus with half, so this is 7 over 2. So we got 5 over 2 and 7 over 2. So this one over here is when x equal to 0. So if x is equal to 0, we got y equal to -2, 3 minus 0 plus with 1. So -2 times 3 plus 1, which is -5. So that value over there is -5. And this is y equal to -2 minus x plus with 1.